Happy Friday, guys, and welcome to another episode of Let's Talk Dubs. I'm your host, Bill T. Well, it's Friday, and it's coming up on the first weekend, last weekend in May, first-ish weekend in June. Sunday will be June 1st, and that means we're going to be headed to Southern California for one of the events kicking off. It's the VW shows weekends. The first thing we're going to be hitting is the DKK Cruise Night. Second thing we'll be doing is the RVA show on Saturday. I know Octo's going on, but you've been there once, you've been there 10,000 times. So we're going to be showing Zorba down at the RVA show. So if you guys are down there, come on by. And then after that, we're going to head over to the open house at ISP West. And then we'll also wrap up Sunday at the VW Revival. So if you guys are out and about this weekend, stop by, say hey, see what's up, check out Zorba. Looking forward to seeing update. There's been an update on the Der Kleiner Cruise. That location has been changed. The new location is the Colony House at 401 North Anaheim Boulevard in Anaheim, California. So make sure you know. It goes from 4 p.m. to 8 p.m., and it's going to be today, Friday the 30th. So we're headed out the first thing this morning. Going to get set up at the hotel and then cruise on over to the Der Kleiner Cruise. I'm also bringing Wayne's car with me. Wayne's the last car that Buddy Hale's built. It's been a bunch of the hot rod shows. So Wayne Callahan's coming out with the 60 watt. So you guys will get a treat by checking this car out. It's a pretty rad car, and an unbelievable amount of work's gone into this thing. And so we had him on the podcast a little bit ago, and it's the first car he's ever owned. If you guys like this podcast, make sure you support those that support Let's Talk Dubs, like VW Trends Magazine. Go subscribe today so you never miss an issue. Not the same old magazine you see on the shelves everywhere else. This magazine has high-quality features, how-tos, and cars you don't see in every magazine. So go check them out today at vwtrendsmagazine.com. Also, Ross Wolf, where do you get your high-quality aftermarket performance parts designed and built by VW enthusiasts for VW enthusiasts? You go to Ross Wolf. That's right, rosswolf.com. Go check them out today. Why don't you get some Viton gasket sealant? I mean, this podcast today is about specifically people bringing modern technology into the air-cooled scene. That's what Ross Wolf is doing. So go check out their website today at rosswolf.com. Also, use the code LTD10 for 10% off anything you buy from Ross Wolf. So go today to Ross Wolf's website and pick out some stuff. Get some jewelry for your motor, some quality aftermarket parts, maybe a high-performance 36-horse aluminum oil cooler. You get something like that. Locking dipstick, one of my favorites. The cool rad velocity stacks. They got a ton of cool parts in there, so go check them out today at rosswolf.com. And don't forget to get your 10% off by using LTD10 in the checkout window. Icon pistons. You guys want top quality, high performance pistons. There's only one piston to go with, and that's Icon pistons. Currently, they're made in 85.5, 92s, and 94s with 3 different pin heights. Go check them out. Where are you going to buy Icon pistons at? Well, I'm going to tell you that in just a minute, but first, let me pump up the pistons a little bit. These are made from 4032 alloy, which allows you to run tighter piston-to-wall clearances so you can get down, keep that compression, and make that motor put out maximum power. They've got 2 1.5 millimeter top rings and then a 4 millimeter bottom ring, which makes getting new rings for these things a lot easier. And also each piston gets M42 skirt coating to protect against dry startups, as well as give an extra layer of protection. The skirt profile is optimized for stability and performance in boxer engines. And how would these guys know? Because these guys make millions of pistons every year. And now the Big Boy Piston Company put out a line because there's a VW dude that snuck in through the back door and said, hey, boss, let's make some Volkswagen pistons. So the highest performance pistons that you can get right now, Icon pistons. Go get them checked out today. Where can you buy these Icon pistons? Type E Motorsports, CB Performance, RevMaster, the Dub Shop, and Churco Performance. So go check it out today. You want the best pistons? Make sure you only get Icon pistons. And I appreciate those that support Let's Talk Dubs, and you guys support Let's Talk Dubs as well. Got a couple shout outs today. First one's going to be Robert Fiskus out of Canton, Georgia. He says, keep up the great work. Much appreciated. Appreciate you for supporting the podcast. Also, Junebug Hoover and his wife, Michelle, got to kick it with those guys a couple weeks ago. They happen to be here in town. Hits me up on Facebook through a friend referral. Not sure if you listened to the podcast before. And he came by. We kicked it for quite a while, ran him around a little bit, and had a good time. Came over to George's shop. So him and his wife, Michelle, got to hang out with us for a bit. So appreciate you guys for supporting the podcast. So as of right now, it's 6:15 in the morning. I'm getting ready to launch this podcast. I'm pretty excited for the weekend. Looking forward to seeing a lot of people, a lot of friends of mine, and a lot of you guys that listen to the podcast that I get to see, man. Nothing gets me more stoked than seeing you guys getting hyped by listening to the podcast and getting fired up and working on your car. So I'm excited for that. Let's kick it off. Couple things happening in 2 weeks. There's going to be the weekend of the 14th. It's going to be the DKP 60th anniversary. I'm going to be headed to that, so I'll get more details on that coming up. More specifically, I'll kind of lay that all down for you guys next week. But 2 weeks from now, I'm going to be, 21 days from now, so technically 3 weeks from now, I'm going to be at Ontario's premier VW show, and that's presented by Vintage VWs Inc., and that is the German Air Car Show and Social in Fireman's Park, Niagara Falls. If you guys are up in that area, make sure you guys register, come out to the show. I'd love to meet all you guys from the Northeast that listen to the podcast. I'm pretty excited. Greg's a buddy of mine, and we've hung out for a little bit. He's come to town. There's a bonding experience when you guys have to push a vehicle together. It was me, him, and Patrick, and we just had to push. I took him out in the bus, had a dead alternator, and it stranded us next to almost on Las Vegas Boulevard, but just behind it. So it was a great experience for these guys to get to push the carbon cab. So, not a lot of people have had that experience. Okay, a few. Most of my friends have, actually. But I'm excited to get out there to Ontario's premier VW show, man. So don't forget to go register today at the German Air Car Show and Social. It's going to be taking place June 21st and 22nd. Fireman's Park, Niagara Falls. I'll leave a link in the description below if you guys are in the Northeast. Come check it out, okay? Cross the border. Let's do it, guys. Anyway, I'm excited for that, and I'll see all you guys at that event in the Northeast. So there's so much stuff going on the week that this year's kicking off, and I got lots of cool podcasts coming up for you. One of the ones I wanted to get for you is the one we got happening today, and that's Andrig Miller. Now, Andrig Miller is the guy that developed a flat blade type fan that goes in your fan shroud, and it's supposed to be more efficient. It's got less drag and pushes some more air at lower RPM. So we're going to have him on the podcast today. I got a lot of questions. I've seen this thing around for quite a bit, and that's what I love about our community, man. It's just people that get in there, dig deep, and try to develop new stuff for our hobby. Obviously, our hobby doesn't have a lot of innovation happening from the outside world. It's always got to be us from inside trying to do a little something special. So I'm excited for you guys to get this podcast. I know some of you guys have some questions, and you get those questions answered. Like, most importantly, what kind of name is Andrig, right? So you'll get that, but you got to wait till the end of the podcast for the answer to that question, and lots of other stuff, man. So we go over a lot of details. You can tell Andrig's really into this, man. So I'm excited to be able to bring this podcast to you guys, and let's not wait any longer, man. But I'll see you guys down in Southern California, and make sure you guys show up at the DKK, the correct DKK cruise night, which is going to be taking place at new location for the DKK cruise tonight. New location, and that's going to be at the Colony House, 401 North Anaheim Boulevard, Anaheim, California, guys. So that's happening tonight. Hopefully I see some of you guys out there. If not, I'm sure I'll see you guys throughout the weekend. I'll be at the ISP West Open House. I'm going to the VW, the RVA show in Old World in Huntington Beach, and I'll be at the VW Revival on Sunday. So I'm excited to see all my friends, see a bunch of people out there, and get into it. So I'm excited also for this podcast, you guys. It's a cool podcast, and I know you guys will dig it. So without any further ado, guys, let's get into it. Andrig's air-cooled technology. Andrig Miller, the guy who's redeveloping cooling systems for Volkswagens, on this week's Let's Talk Dubs.
You probably don't know that there's a new Volkswagen out that doesn't look like a Volkswagen. It's got everything that people who like the bug like. So if you happen to see a good-looking Volkswagen, don't panic.
Okay, everybody. So on today's show, out there in the VW world, there's always people producing things and trying to create a better mousetrap, or the technology that we play with on a daily basis is 50 years old at least. And we wonder why there's never been any evolution. And that's because it's left up to us, the enthusiasts. Now, today's podcast, I have Andrig Miller with Andrig's Air Cool Technology. And if you're not familiar with him, go Google it or go check out his website. But he's developed a new fan design, and a lot of controversy comes with anybody creating anything. So on today's podcast, I'd like to welcome Andrig Miller. Andrig, welcome to the show.
Yeah, it's nice to be here. Thanks for having me, Bill.
Hey, well, I'm excited to have you on here because judging by just what I know from what I've seen on the internet, you're a fairly technical guy, and you have a passion to try to do. You've got some skill that you learned in the real world, and you've got this VW passion that you want to try to see what you can do to help the hobby. And, the way we always start the podcast is first, what's your VW story and how did you get into Volkswagens?
Yeah. When I graduated from high school a long time ago now, 1982, I was going to go off out of state to college, and I needed a car, and I had never owned a car. And I was working that summer to save money for going to school. And my dad went off and bought me a 1964 VW Beetle, right? So,
nice.
So that was my first car. I owned it for 2 weeks. I'm driving it back and forth to work. Seemed to be running fine, no problems. And I'm coming back from work, nice hot summer day, and all of a sudden the car just starts slowing down and slowing down and slowing down. Right. And I'm putting more and more throttle to it, like what's going on with this thing? And all of a sudden I start hearing this bang, 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 bang. And then it just it got really bad. And then, I just pulled it over, shut the thing off. The thing was smoking like crazy. I think I'm really lucky it didn't catch on fire.
Right.
But, as you can imagine, the center main bearing, saddle banged out, right? And so the pistons were like hitting the heads, and the whole thing was
everything starts twisting inside the motor, right? Yeah. So that you have your first experience with it. It's baptism by fire, right? You're the coolest kid on the block for the first half a day.
Yeah.
And then delayed maintenance just takes over, and that's it.
I spent the summer rebuilding that car, basically working and rebuilding that car, borrowing another car from my dad, rebuilt the engine. I went through and redid the brake system, did some stuff on the front suspension. Because the thing, it was it was the same age as me. So an 18-year-old car had been around, and I needed something reliable, for school. I was going to be 300 miles away from home. So yeah, I rebuilt that car. That's really kind of it. And rebuilding that car, eventually I had changed out the transaxle in it, did a bunch of other things to it. And that took me through college. And I owned that car, through college. And then I bought a 73 Beetle, got rid of the 64, and I really kind of hot rodded that one. And so really nice engine, et cetera.
Started going toward the kind of performance side of things.
Yeah, I did, and I had that car, I don't know, a lot of years. And I owned Volkswagens of all different stripes. I even owned a new Beetle, a 2001 new Beetle. Today I have a 73 Beetle that me and my daughter built together as a Baja Bug.
Nice.
I have an 86 Doka Synchro.
Oh, wow.
And I have a 66 Carmen Ghia that is, like maybe 40% done. So yeah, I'm just, all through that. And there was a big gap there for a while, like, my career and everything after college kind of like took so much time that I didn't really have, time for hobby stuff. Really just didn't. Got married, the whole thing, children. And it wasn't really till I built the 73 Beetle with my daughter that I really kind of got back into the hobby. So it's like a 25-year gap.
Right.
Even though I owned Volkswagens all that time, I never really worked on them. And in doing that project, what I discovered was that, boy, not a lot's changed in the 25-year gap that I have.
Right,
between
right.
I was kind of expecting some things change. I mean, for good, there's tons of really high quality now performance parts for engines, transaxles, you name it, right? So the drivetrain stuff is pretty good, except there's a lot of products in the market that are, they don't fit well. They don't, I think we ended up modifying a good 60 to 70% of the parts we bought doing that Synergy Beetle, some minor, some major. The other thing that really struck me too was I hate it when all of a sudden I'm working on something and I got an aftermarket part and I'm going to install it. And now have to switch from my metric tools to my SAE tools, right?
Yeah.
And I'm like, why isn't it metric? Everything on this car's metric. I don't want to, and switching back and forth, just your brain cycles, it's just funny, to me, it's like, it really bugs me. And I'm just like, there's no reason this couldn't be done in metric. You can get metric hardware, anywhere, that kind of stuff. And so there's a lot of things that, and so I started this business kind of on the side with an idea of making some products, but never really did anything. And I made
what came to you as like
car.
the first idea? Like, here's what you made one thing. You're like, I should make these.
Yeah, well, the fan actually was the first real idea.
Really?
In terms of doing anything innovative, I'm looking at the kind of market and I'm going, well, you can build some really wonderful high performance engines, and there's very little on the market to cool them properly.
Right.
And so I'm like, I wonder if I can do something with a fan, and so, that was really the first real genesis, the real idea of anything that was, became real. And I really officially started the business. I kind of scrapped the original LLC, started this business in April of 2020.
Now the angle you came at it. Now, you have an engineering background? Where's your background come from?
I was in computer science, in the software industry for 34 years.
Uh-huh.
So I don't have a formal engineering background, but software engineering, different discipline of engineering, right? But
Well,
go ahead.
And now with technology, right? If you're fairly proficient with 3D modeling software and process software, you can definitely look at something and say, hey, what's it? Because right out of the gate, right? So I have a couple Corvairs and I have Volkswagens.
Yep.
Now, the Corvair fan is really similar to your fan.
Mm-hmm. It is.
And interestingly enough, and I got into Corvairs a few years ago, kind of by accident, because there's a guy had a super cool one online and I could pick him up cheap. And then what's interesting is if you look at let's say you're looking at the evolution of the hobby, right?
Right.
Volkswagen was out there in 1938, started their production, and it went in building cars. Then in 1959, late 50s, General Motors decides they're going to get into the air-cooled engine type thing. What's interesting is, as a base platform, they probably looked at the Volkswagen. And then their engineers did something different. If you've ever stood in a Corvair and revved the engine, that fan creates so much suction. It'll pull your shirt off. You know what I mean? Like it really, you can really feel the velocity of that fan. And those motors are standard 2.7 liter. So did you look at the Corvair fan and think like maybe that fan works? How did the genesis of this start to come together?
I did. I knew about it, and I had looked at it. I actually own one now, but I buy a lot of used parts as just stuff to experiment with. And so I looked at it, kind of knew about it. But here was I kind of had an idea of I wanted to set some goals. I wanted it to be better performing in terms of airflow, right? Than the doghouse fan.
Right.
And the problems with it, right, are, it weighs too much. it can fly apart because it's really
Designed for 30 horsepower.
Yeah, and it's 31 separate parts, right? That have been, and actually the stock ones, they're not even welded. They're just tabs that have been bent, right?
Yeah.
Through a little hole, right, to keep them in place.
Sure.
So yeah, they were designed for, like the doghouse fan shroud is designed for really a 50 horsepower engine, right? So, and they do great for a 54 horsepower engine, depending on climate and altitude, but because they're even there maybe a little undercooled under certain circumstances, because obviously Germany's climate's not the same as ours.
Yeah, Germany's a lot like California, I think.
Yeah.
From when I've been there, at least the topography reminds me of that. I don't know what their cycles are. I'm sure they have 4 seasons there, but it's fairly. Yeah. I mean, I was there last summer and it was fairly. I drove a bus for about 2,000 miles, and needing air conditioning was not a thing, over there. Right. So it's not that dry over there.
Yeah, exactly. And so I'm just like, they fly apart. The way they mount, they can wallow out real easy, right? And I don't know, everyone's seen that. I had a customer actually even email me a picture of with a doghouse fan on his motor. He actually broke his alternator.
Oh wow!
Because he revved his engine to 8,000 RPM and it broke his alternator. I'd never seen that before. That was a new one. So I'm like, well, how do I keep them from flying apart? Well, if I make them if they're solid, one piece, there's not multiple pieces, that's a whole lot better. Weight wise, I could go to, and I did a lot of material research, so you're talking about my background, engineering. I kind of had to self-teach myself a lot of this stuff.
Sure.
And I read a lot of engineering articles and just, got familiar with the physics of the fans as well. So you got the fan affinity laws and all those things and really understanding that. And once I really kind of understood that, then, but to weight, don't fly apart, don't wallow out, right? No matter how you rev your engine, perform better, right? So those were kind of my goals. And I'm like, well, the best way to do that, to kind of meet all those things, is try to do an injection molded thing. Yeah. Well, as soon as you do injection molded from a manufacturing perspective, another nice steep learning curve I had to go through, which is how to make all this stuff, right? Manufacturing, you realize that your geometries are limited. You cannot manufacture via injection molding a squirrel cage centrifugal fan.
Yeah.
So I'm like, well, that kind of leads me to a radial blade design like the Corvair, right? So that's kind of how I got down that path. And I probably did, I don't know, probably close to 120 prototypes.
Oh, wow.
Before I got to what I ended up, shipping as a product.
Now, these were things that you put in a mock-up that you had for testing?
Yeah. So what I did is I bought a 3D printer, and now I have a lot of 3D printers.
Right. You're trying new technology, and the technology you're using for the medium is constantly evolving every 6 months.
Yeah, exactly. And so I just would 3D print them, and I came up with a way of testing them, and you can. I think I may have done a blog post on I don't remember. I've talked about it a number of times. I don't know that I've ever done a video of it, but I have this whole setup for airflow testing that I created. That is based on an ATSM standard for airflow testing. So it's like, they give you essentially the dimensions of everything that needed, how to measure, so that you get repeatable measurements, right? And the measurement itself isn't affecting the actual airflow. So I have a mock-up motor that it's empty on the inside. It's just a crankcase, cylinders, cylinder heads, right? With all the tin and everything on it. Yeah, all the tin on it, all the proper tin on it and everything. And of course, fan shroud. And then I had to actually cut away a big section of the bell housing of the crankcase because I made a very large long diameter tube that then is sealed against the air inlet of the fan shroud. And then I have a pitot tube inside there that actually does the measurements, and it's hooked up to a manometer. And a manometer is a pressure differential instrument, right? So what I get out of that, I got two ports on the pitot tube that feed to the manometer, and the manometer can read both the airspeed and the pressure differential. And then it can calculate standard CFM off of that, right?
Oh, okay.
So once I got that going, right, and could measure this thing, like my prototypes, my early prototypes were awful in terms of, they were much worse than the stock fan.
Right.
It took me a while to understand, what makes a fan good in terms of being able to increase its airflow. And eventually arrived at what I arrived at with what I now call the Evolution 1 fan. When I initially put it out on the market, I just called it the lightweight cooling fan. And so that's how I got to that. And it was really just an iterative process of try this, how many blades, right? I mean, the Corvair fan has like 11 blades. I don't know why they do an odd number, but it's interesting. It's 11 blades.
And I think they have an early and a late fan too on Corvairs.
They have an early fan and a late fan, but the early fan was a squirrel cage fan, just like the Volkswagen. So the late fan is what moved to the radial blade design.
Yeah, and I think the difference in the early and late also from like the high production ones is the vane design maybe.
Yeah. So that's kind of how I got the first successful product out there.
So let me ask this question: when you set your initial mock-up, right, you had to get some baseline numbers as far as this is what I'm starting with, right? And I can envision it in my head. You can set up a mock-up motor, and you can set up you can almost put like a generator or some sort of like an electric motor inside the engine where the stock pulley would go. Set it up like a stock pulley setup, and just have a switch where you can turn it up to that whatever RPM you want, right?
Yeah, and that's what I do. I actually have an electric motor. It's actually hooked up right to the alternator. So I just created adapters between the electric motor and the alternator. And so I mount everything together. You got the regular backing plates, everything together. And of course, it had the stock fan in there in a stock OEM fan shroud.
And now what kind of...
spin that electric motor just with a switch. And then the thing about electric motors that's great is you get two benefits of that. One is it always spins at the same speed.
Right.
Second is it will draw the number of amps that it needs for the horsepower required to turn the fan, right? So I can actually measure the horsepower draw very, very accurately, much better than you can do on a dyno. I've got horsepower, measurements for my fan versus the OEM fans, et cetera. I've posted a lot of this on my blogs and stuff, but so I have that. And because it always spins exactly at the same speed, that also makes it very easy to, reproduce the results and compare the results between different fans.
And now, I have a couple questions. Doghouse. So the original cooler is non-doghouse, right? The second cooler is doghouse. Yep. And between those two, which is, I guess the efficiency is equal to the required performance, right? But do you see a more CFM of air with a non-doghouse versus doghouse, or what do you see difference?
The doghouse does definitely, will produce more because the way that Volkswagen designed the fan shrouds is they're just on the air inlet, on the inside of the air inlet. There's a structure there. There's some sheet metal in there. And in developing my own fan shroud, I've kind of figured out that that's really not a good thing to do. But
what do you mean?
When they design these things, there was no such thing as CFD, and there was no such thing as simulation software that tell you how the air is flowing, right? So
right.
they did a lot of this stuff by intuition, right?
And analog meters for results, right? We figured
And
this will
analog
work.
meters, exactly. So, but that structure it follows the curve of the inlet of the fan itself. So, and that's what limits the space in the fan shroud for the fan itself.
So there's like an internal. So
Yep.
okay, I think so. If you dissect a fan, it has kind of like a snail shell design on the inside to kind of whip the air around. Was that what you're talking about when you're
Well, it's almost like the fan itself kind of has a velocity stack on it, right?
Okay.
And then there's structure inside the fan shroud that follows that curve.
Right.
Because they really, in their thinking, they want all the air to just go right in the center of the fan, right? They don't want air to be really flowing on the outside of the fan, but really that just creates a restriction. But they didn't. It was fine. So you can only fit that 28 millimeter wide fan in the early fan shrouds. So because of that internal structure, so you can't fit a doghouse fan, a wider fan, a 34 millimeter fan. Right. I'm talking about the height of the blade itself,
sure,
not the height of the total fan, because the blades are 28 and 34, but they're like 30 and 36 millimeters. You know, if you just measure them on the outside.
Right.
But anyway, that's so the doghouses definitely flow more air because they're designed to accept a bigger fan.
Right, right, and they also move the cooler out of the way. And put a little veining. So I'm curious how that affects it.
Yeah. What's interesting about that is the early fan shrouds, the non-doghouse fan shrouds, the airflow is very imbalanced. About 60% of the air is going to the 1-2 cylinder side, and 40% is going to the 3-4 cylinder side. So a lot of people, when they think they see the doghouse fan shroud, move it and doing the offset oil cooler, right? Taking the oil cooler out of the airstream,
right?
Was to fix the number 3 cylinder overheating problem, right? Yeah. And there's truth to that, but that's really the real reason number 3 was really bad in the earliest engines is because there's so much less airflow going to that side of the engine, period.
And that's just by design.
And so this is again, I don't know. I don't think they cared that much to get it super balanced, because of the horsepower they were trying to, that they're, dealing with in terms of cooling. You're talking about, 25, 36, 40 horsepower. And they're really not that high, but they're, that's the.
And they're probably more concerned about, okay, it's within the operating temperature. Sure, the side's hotter than that, but it's doing its job and it won't, quote unquote, overheat at this rate.
Right. And so when they designed the doghouse, what's interesting is they stole the air from the 1-2 side for the oil cooler. So it's actually fairly balanced. It's about 5% off. It's still like 55% of the airflow is going to the 1-2 side.
So they restricted the air. They restricted the air going to the 1-2 side.
They actually just pulled some of that extra air, right, and sent it to the oil cooler because there was already extra air there. So, and so there's a little scoop inside the fan shroud on the 1-2 cylinder side. That is the scoop that, that air goes into, and then it's diverted back to the oil cooler, kind of underneath the air inlet. So it's pretty complicated design when you really think about it. I mean, I've read articles where people talked about, Volkswagen spent like $1.5 million developing that fan shroud, and I wouldn't doubt it. Because it's pretty complicated what they did in terms of how they direct the airflow. Right. It does result in better, just better cooling overall. You get more, it's better balanced. You obviously don't have the air being heated up by the oil cooler anymore on the 3-4 cylinder side. So that's better. So yeah, I mean, that was a big step up actually for Volkswagen in terms of what they did there engineering wise. It was quite good.
And so your Evolution One fan, that the
Mm-hmm.
design of that was intended for what specifically?
For just fitting in, your doghouse fan shroud, basically. So it's just can I take what they did and just, go up a level in terms of, performance of cooling. And I was able to do that. I mean,
So
and what I know now
what
is
were
actually kind of surprising.
what were your goals? Like originally you said, I want to have more airflow at lower RPM and less drag at higher RPM. Was that
Yeah. Yeah, my goal was make it a lot lighter. I really wanted 90%. I got to 73%, and really no way to get to 90%, and have a material that would hold up. But you said lofty goals, right? And I'm like, if I was 5 to 10%, better airflow, that would be, that was
an
one of my
improvement.
goals.
Yeah.
Yeah, and of course, being able to sustain high RPM levels without the fan flying apart and all that. So yeah, I set those goals and I got to 73% in terms of the weight. So I was very happy with that. I ended up with a little over 11% increase in airflow over the stock fan in the same envelope, which is
That's more looking at your chart on your
yeah.
blog. That's
Yeah.
that's a greater increase than from non-doghouse to doghouse.
Yeah.
That looks like a 6% increase.
Yeah. Yep.
And so then you're 11 on top of that, and then what types of things? Because what's interesting is when you put a blog post and you think nobody wants to hear the quote unquote boring details of fighting through every tooth and nail. When you think like, oh, here's a great idea, no one's thought of this, then you do it, it's a complete failure. Or then you start doing this and you get result A, but the side effect is this. What have been some of the challenges that you noticed through the prototyping process of what you thought? Like, what was your biggest bummer where you're like, this is going to be, I know this will do a big deal, and then you did it and it was like gave you the opposite result?
Yeah, I mean, I never really got opposite. The big thing, I think, the biggest thing was the shape of the blade, the fan blade, making it fit, and yet
inside the
not making
shroud.
making it fit inside the shroud, maximizing the surface area of each blade, while still fitting without hitting anything was difficult. And then what's called the fan on a radial blade fan like this, or even like a turbo, compressor wheel is just basically a radial blade fan. The fan root design, right? So it's, in other words, where the blades attach. That proved to be maybe the biggest obstacle as well in getting something that performed really well. So just that curvature, again, and it interacts obviously with how much blade surface area you have, so that you can get laminar airflow, as well as you have to put a mounting system in the middle of your fan, right? So I had to figure out a way to make that as small as possible. So that's, I came up with a custom mount. Instead of trying to use the original mount of the original fan, I had to create a custom mount. And that was probably the biggest breakthrough, is when I created the custom mount and shrunk that down as small as possible, the center. That it both elongates the blades and it gives me a more gentle, radius on the fan root to get the smoothest airflow, and the height of the fan as well in the center was another thing that I had to do a lot of different prototyping on to get the optimal height. So, and every one of those, they all interact, those dimensions. You change one, it changes the other two. So it changes the radius of the fan root, and it changes then what your blade looks like and what surface area is. So those three were the combination that was, I had to iterate over the most.
And I'm sure, I don't know if there would be a 3D modeling software that could do something like this. There's so many parameters that you'd have to input.
Yeah.
I mean, it's probably next to impossible to get something that can give you accurate, similar results, because you've got the channel of the shroud that it's pushing through, and then the velocity that you're trying to get, or what you're trying to get, how you're trying to grab the air around the fan, right? Like the different vane structure and design and the arc and the length. So what you're saying is, I'm looking at the fan online, and the Evolution 1, that those fins you're seeing out of the back of the shroud. And then the Evolution 2 has air intake behind the alternator on the front side of the shroud. Is that correct?
That's right.
Okay. So let's talk about the Evolution 1 for a minute. So when you're doing that Evolution 1, the other thing that I think that I don't know if you need to take into consideration, or you found as a result, was different blade designs can create hums, pitch, and harmonic things too. Like you get some harmonics out of it sometimes.
Oh yeah. Yeah. And the Evolution 1 definitely has a nice high pitched whine to it.
Oh, does it? Because I haven't heard one. I've seen this online. And I just wanted to get the details on this. So what does the pitch sound like?
I mean, the higher the RPM, the higher the pitch is, right? But and you hear it much easier because it's higher pitched than a squirrel cage fan. It's definitely, some people don't like it. I'll just tell you that right up front. I've had people really complain about it. Not a lot, but some people are like, I hate the sound of that thing. It's like, other people are like, man, if everyone thinks I'm driving a turbo, car, it's so cool, So some people like it, some people don't. It's obviously louder. And I've done the decibel measurements and all that, and it's louder by quite a bit, but any fan that moves more air is going to be louder. The more air you move, the louder it's going to be. So really not much you can do about that. You can curve the blades, and that changes. That's one of the reasons Volkswagen has curved blades on the original squirrel cage fans, is for sound. When you curve the blades, you can reduce the sound. And I actually experimented with curved blades, but you reduce the performance so much, it's not worth the sound improvement. So that's why the blades are straight. Is really that's what gives the best performance, and that was more important than the noise level of the fan. And I think most customers so far have agreed with me on that.
Well, I think that's one of the things that when I was talking to a week or two ago, I was talking to Gerald Klaus, and with the development on the Type 4 stuff that his dad does, and then you're looking at aftermarket performance stuff in Germany in general. They keep air boxes on the cars so they don't hear the wall of the carburetor. But here in the States, like, we don't really care. We're trying to make the engines louder, right? Like louder to us means more power, right? Whether it does or whether it's on the dyno sheet or not, right? So I think it's you're uninhibited by the restrictions of an OEM manufacturer who's trying to be like, okay, we want more, but it needs to be quiet. We want this, but it's got to be like that. So there's always the push pull. So when you're in the wide open aftermarket, you're free to do whatever you want. And if it makes noise, sometimes that's better, right? Straight cut gears and, all that stuff. So now with the design, so you got to the design of this, and then when did you feel like it was ready to release on the first one from inception? So were you working on this for like a year before you took it to the Samba, which is like...
It took me about 8 months before I was able to, and then before I took it to, manufacturing. And then how long did the manufacturing they had to make a mold, right? So, which is not an inexpensive thing to do.
Sure.
And finding somebody who could make the mold, at a reasonable price was fairly difficult. But, I kept hunting around, and I found a small company in Detroit, Michigan that made the original mold, and they're still, making the product for me today. So the Evolution One is made completely here in the U.S., which was kind of a, some people don't
cool.
care, some people care, and I try to do almost everything I can in the U.S. I do have some stuff that's not U.S., but because there's just no way to make it, reasonable price, because it is a price sensitive market.
No, there's no question.
So,
Well, there's layers of this thing, right? So the couple layers I want to talk about is, first, you take it to the Samba, and how are you received at the Samba? Like, because the craziest part about the Samba is everyone's an expert on there.
Yeah, and people were talking about it obviously when I posted an ad for it, and everyone's like, oh, I had a lot of people. I want to be on you got a waiting list? I'm like, well, I don't, but I'll create one if you want, and put you on the waiting list, and then I'll notify you when I get inventory and that kind of stuff. And so in that window, of course, people are like, what is it made out of? It isn't going to, it's never going to hold up. It's just going to melt, all these kinds of things, and
Right.
then I responded. There was a big long thread, I think, on the Samba, that I chimed in on, kind of all over the place. And some people were like, I just want one, this is like great. Other people were like, I'll wait till, a bunch of people will use it and we'll see. Right. Some people were like, oh, I'd never use that thing. So, that's the kind of response we got on the Samba. And I took them through a lot of things that we're talking about today, took people through, kind of how I developed it. I don't really tell anybody what it's actually made out of. I keep that as a trade secret. The work it took to come up with the material that would work fine, last, not have problems,
Right.
and be lightweight, and can be used in injection molding. That was a big effort. And so the number of materials I, kind of went through trying to figure out which one is really the right material before I landed on what I ended up with. That's why I just don't tell anybody. But, it's a very strong material, yet it has enough flexibility. So there's not an issue there. And its heat deflection temperature, which is the temperature at which it, when it's put under pressure, it starts to soften, right? Not its melting point, right?
Right.
Is over 500 degrees Fahrenheit. So your engine's going to be on fire, right? If you had that happening. So it's not going to melt, and it can take cold weather, hot weather, it doesn't really matter. It doesn't, and its thermal expansion properties are similar to steel. So it's a little bit more than steel, which means, as the engine thermally expands and the sheet metal thermally expands or whatever, it's basically thermally expanding at the same rate as everything else. So you don't get, a lot of people's like, why didn't you do it out of aluminum? Like, well, one of the problems with aluminum is it expands a lot when it gets hot,
Right.
And so that you'd have to kind of take that into account and make basically a smaller fan. Plus, just doing it out of aluminum, you'd CNC machine, it's just expensive. So you just end up with, something that is too expensive for most people to buy, and, has additional engineering challenges with it that,
well, let's talk
are
about
almost not worth it.
Let's talk about that for a second, right? So you're already going down the road of a composite fan, right? So the fan itself in a Volkswagen engine, once it gets up to operating temperature, it's hot and it's going to warm the air, right? Just because the metal itself is hot.
Yep.
And I've often thought, like, when I see people with, because I remember seeing some guy had some hokey turbo set up on something, but the guy used all the boost pipes out of PVC. And I thought, it's pretty interesting because they're not going to get an excessive amount of pressure that PVC can't handle. But in addition to that, there's no thermal transfer. Like the PVC will not get hot like
Right.
metal will, and it has a,
Okay.
it releases the heat. And so I thought, I keep thinking when I look at Volkswagen stuff, thinking like, well, why wouldn't someone just make all carbon fiber shrouding? Like I have a carbon fiber shroud on my, and Volkswagen or Porsche went to fiberglass, right? I'm a big Type
Yeah.
4 guy, right? I like Type 4s,
Yep.
and
Yep.
I've got I had my first Type 4, and the cooling system that I have on there is the 911 style shroud, and
Yep.
that's got it was the one Sharp built in Australia, right? And I
Right.
know, especially when you start talking, and I brought up two names right there that are pretty sensitive, right? Jake Raby,
Yep.
who has done
Yep.
a lot of testing of
Yep.
different fan shrouds, and I do have a DTM that I bought years and years ago. I've never put on anything. It's just sitting in my garage, like probably like
Yep.
a third of all Volkswagen aftermarket parts never get installed. And
Yeah.
and what's interesting is, I love the look and design, the look of the 911 style shroud,
Yeah.
but
Yeah.
in a stock Type 1 configuration, that setup seems to be, it really looks awkward in a Type 1 in an engine compartment of a Beetle. And so if you can make something work with that stock Type 1, but I've often thought, like, how come no one's making all the tin, like replacement engine tin, out of composites? And I wonder what the effect of thermal transfer, because I almost think there's two ways to look at that, is
Yep.
the metal that's connected to the motor help dissipate the heat from the core motor itself, like
Yeah.
almost like cooling fins, or would a motor run cooler if all of the components delivering air were non-thermal
Yeah.
or thermal resistant, I guess you would call it, right? Because you look at the
Yeah.
new
Yeah.
LS motors, the whole intake manifold is injection molded plastic.
Yeah, yeah, exactly. And I can tell you the very simple reason why, because I do have my own fan shroud now, as well, and it's just sheet metal parts that I weld together, right? So they're laser cut sheet metal parts I welded together, and I have been actively looking for a way to do that as a composite, like a fiberglass. Do the exact same fan shroud, but fiberglass. And I created a 3D model of my fan shroud. My modeling of my fan shroud is as parts, right? Because they're welded together. So, so I created a new model that was suitable for like composite manufacturing. And the thing is, you want smooth surface on the outside and the inside.
Right.
So,
And
so you can't just do
is not smooth.
fiberglass layup, and just, manually kind of do it, because you're just going to end up with, you're going to have one side where you can have a smooth surface, and the other side is going to be all rough. And of course you want aesthetically, you want that smooth side, but on the outside, but performance, you want the smooth side on the inside. Right. So,
Right.
So I contacted several different composite manufacturers around the country with that new model, using a process which it's going to escape me the name of it, but it's a way to do composites similar to how you do injection molding, and I'm forgetting the name of it right now off the top of my head, but what allows you to have essentially fiberglass that is smooth on both sides.
Oh,
so I'm like, okay, so can you quote me, what has to be done with this? And you quote me, well, they have to create a big, huge mold. And this particular process, it's a big mold they have to do out of aluminum, right? So just think about an aluminum mold for a full-size fan shroud.
Yeah.
So the cost of that was really, really expensive.
It's got to be
probably triple the cost.
$50,000 just for the mold.
Yeah, exactly. I think it was more than that, but it's just a lot, So you're like, well, I'm never going to make enough of these, right?
Yeah.
The volume wise to really ever recoup that mold cost, right? So that's what really that's the kind of thing that kind of stops people from doing that. It just ends up being too expensive. And if you can't sell thousands of these things, fairly quickly, you're just never going to recoup the upfront manufacturing costs. So,
Right.
and that process is used a lot in the automotive world by people like you mentioned the LS engine, people like General Motors, obviously Ford, et cetera. They, because they're making many thousands of these things, tens of thousands, hundreds of thousands of these things. And so they can definitely do that. But you're right. I mean, it'd be nice to be able to do that. And actually, I've thought about, it's not as big of an investment actually is buying a 3D printer that's capable of printing a fan shroud.
Oh, really?
And that's possible. It's just that's also very expensive, but it is less expensive than the mold. So that's something that maybe down the road someday, if the business does well enough, that I would investigate and do more of, because it's also then becomes one of the issues with I sell those fan shrouds raw. Because the prep work for painting and powder coat or whatever, for me, just do by myself. One, it's too many hours. I'd have to charge people for it. It becomes too expensive, that kind of thing. So,
well, and we're kind of a DIY market. A lot of guys here,
Yep.
They're like, well, let me supply my own parts. You build my engine, or let me do
Yep.
this and do that. And it's always, and I think the problem is, and it's not because the demographic now in the air cooled community is like people have money. So if you had your fan and you had, what do you sell your fan for? How much do you sell that fan for?
I sell the Evolution 1 for $129.
Okay.
And then the Evolution 2, I sell right now. It's on special pre-order because I don't have the inventory. It's being shipped to me now. But the regular retail price for that will be $179.
Right. And so let's say you had a different version that was a different composite or a higher RPM version or something, but it was like the deluxe one. I mean, when you look at stuff, like when you start comparing stuff like pricing, when you go to Jake Raby's site and he's like the other end of the spectrum, there's somewhere in the middle, because we're all statistically in a demographic where we have more discretionary income, which is why you see so many cars being built that are really high-end cars, because we're part of the more money than brains club sometimes. And the thing is, right, but then as a manufacturer, you go to the Sam Walton theory, right, where it's like, well, you can sell to the masses and live with the rich, or sell to the rich and live with the masses, right? So you can sell 100 of the coolest things or 1,000 of the most profitable things, So, I mean, I guess there's kind of that double-edged sword, and then also with you being in that arena of like new technology, trying to do something better, there's always that push. So now, when someone buys the Evolution 1 fan, what can they expect? Let's say, hey, I'm putting it on my 1600, and will it free up horsepower? So what is the features and benefits of the Evolution 1?
Yeah, it's never gonna. Well, I shouldn't say never. You have so many kind of options. As soon as you've now kind of increased your cooling capacity, right? Mm-hmm. Depending what you need, like, so you're talking about just putting on a 1600, stock engine. Obviously you're going to improve the cooling. Your temperatures are going to go down. Your cylinder head temps are going to go down. Your oil temps are going to go down. I never tell anybody, it's going to go down by this much or whatever, because every engine is unique. Your climate is unique. Really don't know what's going on with your motor. So, it's very hard to say exactly, but I've had customers, I had one customer, he's like, oh yeah, my oil temp dropped 45 degrees.
Really?
Right. And so that's on the extreme,
right?
Of what I've heard from customers. But, so on a stock like 1600, all right, you're going to get 11+%, a little over 11% increased cooling air. If you need that, right? If you need that extra cooling, because maybe you're just in a hot climate, or you're in a hot climate that's also altitude where the air is thinner, whatever, essentially what you're going to do is your engine's going to last longer, mm-hmm. right? Temperatures are going to go down, your engine's going to last longer. But let's say you don't really need all of that. You need maybe 5%.
Right.
You know, you could then go down to like a power pulley, slow the fan down, still get an increase in cooling capacity with a power pulley. Cut that in half, let's say. I've done the calculations. It's something like that. And then actually reduce the horsepower draw of the fan, because the fan laws are very well known, and their laws, it's not a theory that has to be proven. So their laws,
Right.
and one of the fan laws is if you increase airflow, you increase the horsepower that it takes to create that airflow, right? So
Right. There's no
my
free
fan
lunch.
does,
Yeah.
there's no free lunch. My fan does require more horsepower now, but it's very small because it is more efficient. Because in efficiency, where fans are concerned, the calculation is really just the ratio of airflow that the fan produces over the power it requires to produce that airflow. So at 2,156 RPM, it's about a quarter horsepower more that you need, and then that goes up because it's not linear. It's more than linear in terms of how horsepower draw goes up.
Right.
So all the way up to 8,000 RPM, it ends up being at like a few horsepower more at 8,000 RPM.
But in theory, it should stay together at 8,000 RPM.
But it'll stay together at 8,000 RPM. And I have a test engine that I test all my stuff on, and I rev that engine to 8,000 RPM. So, and I use my own. I made it myself, but my own serpentine style pulley system, right? Belt system,
right?
Poly V belt system. because there's less belt slip. So, the fan is spinning much higher.
That's the other thing that I read on your blog was talking about the belt slip on a V belt versus like a serpentine, which is obviously why, what's interesting is when you look at the automotive industry and you look at over the past 35 years in technology and everything that they've done is to create, it's been less of an increase in volumetric efficiency and more of an increase in efficiency based on technology. In other words, less belt slip, getting more production out of the alternator, the air conditioner, all those types of things. And like when it comes to power, it's like it's less about shoving more volume in there and burning all of the fuel, direct injected heads and those types of things, which is just it's become efficiency, and getting more of everything that you're doing with intent.
Right. Yeah, and so you pay a little bit of extra horsepower draw at the top at kind of very high RPMs, but for the most part, when you're driving around, just normal driving, even highway cruising or whatever, you're using very, very little extra horsepower, but you're also cooling the engine. And so one of the things that I tell people, especially people who are racers, is like, you need to now really think about your tuning because of you're cooling the engine better, right? So when your head temps drop and your oil temps drop, that usually means you can do things like, I can add more timing from a tuning perspective.
Sure.
And I might make more horsepower and be more efficient and actually have, and if you're just street driven, better cruising on the highway, better fuel economy, cooler engines just run better, right? Generally speaking, and can be tuned a little bit more aggressively if it's a race engine. So, in a lot of ways you can gain much of that back through the additional tuning that you can do because you cool the engine better. So
now have you seen cylinder head drops from your own personal testing, like cylinder head temp drops?
Yeah, absolutely. More air. I did have one guy one time on the Samba comment that, and I never responded to the comment because I didn't want to insult him. He's like, more cooling air is not always better. And I'm like, I don't know if that's really true from
Right.
standpoint of, these engines really, aren't cooled, perfectly to begin with, even stock, right? And then even you just build a mild engine. These days, you build, buy an engine kit from CB Performance, right? And They have different horsepower levels, and they'll say if you build this kit correctly, you're going to get this much horsepower, right? It's very accurate, actually, what they've done as an example. But you buy one of their mild kits, and you're over 100 horsepower. Well, that's like double.
Yeah, it's double the power of the
so
factory.
when you think about if it's double, it's also double the number of BTUs. Because the BTU per horsepower is linear, right? So you're actually doubling the amount of heat that engine's creating.
Well, it's an interesting point you bring up, because in this world of everybody with aftermarket stuff, right? Here are the goals, right? Everybody wants an early car.
Yeah.
Early cars did not have doghouse fan shrouds. Mm-hmm. What did they do when they came with the doghouse fan shroud? They vented the deck lids. All the deck lids were vented because now it was drawing more air. And and I'm wondering if anybody's ever done that test, right? Like taken two back halves of a vehicle, sealed off the engine compartment, and put a fan on the bottom, sucking air through the factory vents under the rear window, and then what a difference it made to add. I think the first car that has vents is like 10 vents on the deck lid. To where and that was simultaneously when they did the doghouse cooling setup so that it can pull more air. So now there's a couple factors here, and I want to see how you've dealt with these, because there's traditional driving Volkswagens and there's modern driving Volkswagens. So modern driving Volkswagens are bigger motors in most spaces that allow less airflow, right? The early car late model motor. Second, freeway flyer transmissions, which I think the factory motor is designed to run at like 3,500 to 3,800 RPM on the highway, right? And I'm only grabbing that from the sky because it should be 3,200 at 65 miles per hour. Correct.
Is what it should be.
And no one drives at 65 miles an hour. So
exactly.
Yeah. So now, and that's one of the things, like with one of my buses, I had the transaxle geared to where I don't even go into fourth gear until 65. That's when I enter fourth gear, and because I run a big Type 4, and at GPS cruising at 75 miles an hour, I'm at about 2,800 RPM. Now in that particular motor, I do have a 911 style shroud, which is designed for that type of efficiency to run and pull that air. And I think part of the issue, right? Everybody's trying to lower their RPMs, have a higher top speed, bigger displacement, less available air to cool the engine with from the intake side, and make it perform. And sometimes no one actually takes a step back and says, here's what we're doing as a hobby, right? We want the early cars, deck lids closed, no additional air intake to cool the motor, increase the displacement, which increases the temperature, and then lower the RPM on the freeway. We want to cruise at 2,000 RPM.
Yeah.
So
it doesn't work. It doesn't work, right? I mean, you just end up with an overheated engine. But what people I think don't really realize that they're overheating their engine, because most people just depend on oil temperature. Almost nobody has a cylinder head temperature gauge. Right. Everyone should, if you ask me, but because that's really what tells you what's going on with your engine, not the oil temperature. Because it's very easy to hook up an external oil cooler. And in these days, there's really good ones on the market with fans on them and all kinds of stuff, makes it, and, everybody's full flow, right, these days as well. So, so it's pretty easy to do that, and keep your oil temperatures down. But that doesn't mean your cylinder head temperature is anywhere within, reason. And so because a lot of people confuse in terms of cooling, the technology, that people are like, well, the engines are air cooled and oil cooled, and there's truth to that, but it's only like a quarter true. Real oil cooled engines, which some motorcycles have, they actually has a passage around the combustion chamber that the oil actually goes through, like a water cooled engine, just with oil. Right. That's a real oil cooled engine. That's not what happens with VW engines. Right. So, so cooling the oil with an external oil cooler and keeping your oil temps down is great. Should definitely do that. But that does not mean you're not overheating your engine. And the overheat condition on a stock head is about 405 degrees. So if you hit that, you're definitely over. You're likely to, on a stock head. Just keep this,
Right.
sane here, on a stock head. And so if you hit those kind of temperatures on your cylinder head, then you're likely to drop a valve seat, right? Break a valve, do something like that. Now on the aftermarket heads, the castings are much, much better these days, right? I mean, much better than anything,
Sure.
that they used to have. And so the heads can definitely run hotter without those issues, although they still have the same interference fit for the valve seats, right? So you get into those, head temperatures in the 400s, you're really, really pushing, your luck in terms of cooling, keeping your engine together.
Yeah.
So regardless of your oil temps.
So how are you? So you have a car you drive with your setup on it?
I actually don't right now, but I did, but I don't at the moment. But
So do you have?
so what I recommend to customers is really, like, if you have an early car, I tell people, look, you really should run, like deck lid standoffs. I know it's not popular, but you're definitely there. Even without my product, they already need it. Right.
Right.
The other thing I tell them is, if you can find, unfortunately, they're hard to find and they're very pricey if you can find one, is a convertible deck lid.
Sure.
For the same year car. And you can get new ones now as well. They're just pricey. So unfortunately, they're like $400, $500.
What's going to make the difference? I mean, like if you're looking
Yeah.
at the challenge that I just laid out with lower RPM, bigger displacement, and you're starting off with, I'm going to take bigger motor, different cooling system, and I'm going to shove it in a smaller space that was antiquated and expect better performance, which is kind of,
right.
It's a little bit of that. So you're doing all of that, and you want better and more, and you want Volkswagen reliability, because that's what really pushed the car over the top, was like the thing would just run forever no matter what. And and I think our generation has gotten so used to everything being messed with so much that it's just terrible, Now go ahead.
Yep. So those are, so you got a low cost option, which is deck lid standoffs. You got a higher cost option, which is get yourself a convertible deck lid, because they have the vents in them, because there were no below the window vents on the convertibles, right? So you double that, and you end up with something that is period correct from a standpoint of it is the same deck lid. It just has vents in it, right? Obviously, you could vent your own deck lid on your own if you wanted to, and that would be another low cost option. And I've been thinking about developing kind of like a Weber window product, except make it vented. So in other words, for people who got these big motors in these early cars, there's already a problem with space, right? And that's where the Weber windows kind of come into play, to give you a kind of a hatch there. And I'm like, well, if you made that a vent, a removable vent, right, then you would actually increase the airflow into the engine bay.
Now you're talking,
that way it's kind of hidden.
You're talking an air intake where the Weber window. So if you made a removable, because what they could do is take the cover and put a filter on it to kind of filter the air. Because the problem is you're throwing.
And you don't really need to do that. You can. I have a design where it's vented in overlapping vents that where water and dirt and stuff wouldn't be able to go through, but air would.
Oh, really?
So it's a tricky design, but I've created a prototype for it. It's kind of on the back burner at the moment, but because I've got bigger things I've got to mess with right now. But it's an idea that I've had for a little while, and because it's like, if you could vent from the side there, then people can have a totally closed deck lid without modifying it. Don't necessarily have to buy a brand new convertible deck lid, right, to get vents in it.
Right.
And have the same look, but then have, something there that's kind of hidden out of the way that does improve the airflow into the engine bay. So I don't know. We'll see where that goes, but that's kind of the idea I've had. But that's kind of what I tell customers, kind of your options are, at least today. And then, of course, if you've got a late model car, there's plenty, ventilation. It's pretty over-engineered in terms of how much, ventilation they added versus how much cooling was needed, how much airflow was needed. So
what a lot of people have been doing, and this might be a thought for you, would be you make a vent that goes underneath the license plate that you can actually cut out and rivet into the deck lid that would go under the deck lid if people are really concerned. I mean, if you're buying your fan, you're buying it because you've already got some cooling troubles, right? Yeah. I mean, I would think, because someone, if they're looking for a fan, they're thinking, how do I get this to where I don't have these issues anymore? Yeah. So I think it would be a natural add-on to something like that. But, it was funny you brought up, oil cooling and air cooling for the engine. Now, so when I was at the SEMA show not long ago, and I've been waiting to get him on the podcast, there's a guy, and it's Z-Tech. I can't think of his name right now. I've actually done a video with him that I posted on my YouTube channel where I interviewed him at the SEMA show, and he makes a on-dash removable cylinder head temp. It actually has 4 thermocouplers on it that you can get 4 different readings, or you can he has these rings that go around the base of a spark plug that will give you your cylinder head temperature for each individual cylinder. And it's really, really a slick setup. It's a CAN bus setup, and it works. I talked to him in length, and he's a guy from Austria, and he's like, look, what makes my thing expensive, it's not the digital reader, it's the thermocouplers, because you have to get good thermocouplers to get accurate readings. He says the ones that I sell are the best. And what's interesting is there's been so much fraud from overseas that, he uses these specific EGT sensors from Bosch that go right into the exhaust. And he says, I have one that I gave to the guys from Bosch that I got from an overseas company. It's stamped Bosch. It says Bosch. It is not a Bosch product. And it's really interesting that people can get fooled by stuff like that. But it's one of those things that I got to buy a couple of those setups just so I have them in my cars. And he says, I can just sell you the brain. It's cheap. He says the expensive part is getting high quality thermocoupler sensors, because there's and I think that's what it's called. It's like a steel braided line that goes to those cylinder heads. And that's where it has a fluid, I think, inside it, or something inside it that transmits the resistance from the temperature swing that gives you the information that the data is based off of. But it's really interesting. And I think, VW people have never put the time and effort into doing, the average VW person hasn't put the time and effort into actually putting those on there and testing it, because everybody, like you said, goes off of oil temp, right? And so when I've watched these debates online about which cools better, deck lid standoffs or opening the deck lid from the bottom, and which is funny because you look at these things back and forth, you think, well, propping it at the bottom, it would create a natural vacuum. You would almost think, it would seem like it would make it starve for air, but you get a lot of people that swear by it, and then it's and I've seen those. Those threads, with the interesting round shape of the Beetles, right? Even a bus. I think both work, but they work for different reasons. The curvature of the back of the Beetle is too aggressive for the air to stay attached. Right.
And so it creates drag. When it creates drag, essentially what that is the air is then swirling right behind the car.
Right.
and I think it's swirling right behind where the bottom of the deck lid is my guess at the moment.
Kind of a turbulence.
Without like real wind tunnel data or putting a beetle into a CFD simulation.
I'm sure somebody that works in one of those places has a beetle.
Yeah, probably.
Yeah.
You won't know, but I suspect that the air curls up underneath there. And so propping up the bottom, it allows you to suck. It allows that air to go into the engine bay.
Right.
And then the deck lid standoffs, I think, actually work more by the air coming in the sides than it does the top.
Oh, really?
Because once that air detaches it'll detach somewhere like around the rear window back there. Once it detaches, that air is not just going to be rammed down in there. It's not necessarily, although it will kind of act as a little bit of a scoop. But I think most of the air is coming in through the sides. That's my guess. Just kind of visualizing it in my head in terms of how I think the airflow might be working around the car. I think both probably work, and they probably just work for different reasons. And it may not be what I'm saying. It might be, different from what I'm saying. But yeah, it's like, and of course, when you have prop your deck lid open in any way you do that, right? Then your engine gets dirty. It's like just a lot of stuff gets in there.
Yeah.
So that's kind of a downside. But if I'd rather live with that and cleaning the engine than not having enough airflow.
Right. Now,
to keep it cool.
With what you've been working on, so let's talk about the Evolution 2 real quick. So what is the philosophy behind the Evolution 2?
Well, thinking about what, how, is there another level I could take, right? Your Evolution 1, it's a good step, 11% increase in airflow. But it's like, many people are running engines. I talked about mild engine being 100 horsepower double.
Right.
You're talking about street engines. People are running, 200 and plus horsepower on the street. My test engine is produces around 230 horsepower, right? So how do you keep these kind of engines, truly keep them cool? And I'm like, well, we need another step above that. And I was inspired by the Porsche Type 547 engine.
Yeah.
And if you're familiar with that, it was actually an engine Porsche developed for Formula One racing. And it was one of their, I'm forgetting the guy's name. I wish I could remember his name. One of their famed engine designers at Porsche was the guy who was responsible for designing this engine. And of course, the engines are still out there. They're worth like $1 million each, these engines. They're crazy. In fact, a guy that actually rebuilds those engines actually contacted me asking if I could make a fan for him.
Oh, really?
Yeah. So the Type 547 engine, and it was in some of the Porsche Spyders. It was designed to be able to fit into a 356.
Right.
So that's what everyone tends to call the quad cam Porsche engine, right? Because it was quad cam. It was dual overhead cams on both sides, right? So really, really sophisticated, engine. And I think 250 of those engines were made, something like that. So they were in the Spider, they were in a 350. You could get them in a 356 as well, a special, obviously order. That's not. I don't think that was something you could just walk onto the showroom floor and buy, right? But it had a dual-sided fan, so it's a squirrel cage design, but air intake on both sides. And so I looked at that and I'm like, I wonder if there's a way I could do that, but do it with a doghouse fan shroud. It took me a while. And like a lot of things in my life, I don't know if this is true for a lot of people, but for me, usually I dream the solution. Like I was trying to do some stuff in CAD and I was working on it and trying to figure out how I would do it. And then after, I don't know, probably 3 or 4 weeks of really just, I don't know how I'm going to make this work. Went to bed one night and I just literally dreamed the solution. Got up in the morning, whipped it up in CAD in like 10 minutes. And I'm like,
Really?
I think this is going to work. And then I'm like, well, are too small, because it's the same, you have the same, you know, area to fill inside the fan shroud, right? I can't make this thing much bigger.
Right.
So is 2 smaller fans going to be better than one, with 2 air inlets going to be better than, I had no idea really.
Well,
I thought it would be, but didn't know.
And for some of our listeners that don't know, I'm looking at a cutaway image of that, and it looks like two fans are kind of pieced together. There's a front fan and a rear fan, but
That's right.
there's a divider down the center. And
Right.
so this is where you're saying 2 fans, because if you actually look at the fan that's not attached, it's solid on one side because it's got to have that backing that holds the whole piece together, right? So that welded flat face backing that the fan is attached to is that part. So that's kind of a challenge too, connecting the fan and keeping it all together.
Yeah. So, so once I kind of dreamed that up and I'm like, okay, I have solution. It was, okay, I 3D printed the parts, right? And I airflow tested it, with my setup. And it was a lot better. And I'm like, okay, this works. So,
so what kind of results did you get with the Evolution 2 compared to stock?
So the Evolution 2 is 28.9% higher airflow than a stock doghouse fan. So it's another step change up that you get. And it taught me something kind of interesting, right? Is that so the internals of the fan shroud itself, the cylinders, the cylinder heads, the fins, and all that, all those things, provide essentially air friction, right? And a restriction to airflow.
Right.
But not more than the inlet of the actual fan shroud. So, because if I can keep increasing how much air the same system is actually pushing through, that means essentially that the air inlet itself is a restriction.
Right. So, you can only get so much, like, I don't know if they call it terminal velocity. You can only get so much coming through that.
Yeah, through a given opening, and so, but it can push more air down through all the fins and all those nooks and crannies, right, to cool the engine. So I'm like, that's kind of interesting, from the standpoint of just what I learned out of that. And so I'm like, okay, so that's really good. And that's part of what went into how I designed my fan shroud. So my fan shroud is designed in such a way to reduce airflow restrictions, like in every way you can, essentially. So,
so when you started,
that's an aside.
When you started, let's say with the Evolution 2 setup in an existing doghouse shroud, once you started opening up some of the restrictions inside the fan itself, you got more airflow out of it.
Yeah, once you get more air inlet area, right? So because now I have an air inlet on both sides of the fan shroud. So
now you're pushing more air through.
So now I'm able to push more air through, the cooling fins, and out the bottom. And it just shows you there's plenty of space, essentially, right, for the air to go, right? So,
so the Evolution.
So that ended up helping me in how I designed my own fan shroud. So.
Yeah, it's definitely something unique. How many kits have you sold so far?
On what? On which one?
On either. Like, you sold a few hundred of the Evolution 1s and then the Evolution 2?
Yeah, I have. There's more than 600, probably getting close to 700 of the Evolution 1s out there.
And the feedback you're getting from now, you made the diameter of that standard nut that holds it to the alternator a different size.
It's the mount is the way it mounts is I have kind of like a cup shaped mount that the fan presses into, so it's a slight interference fit.
Uh-huh.
And then it uses now it took me a while to do this. I had a custom flat washer and a flanged M12 nut that I used back there instead of that big, huge, nut with the spring washer.
Right.
It's a small M12, nut that's flanged, so that makes it smaller. Now I actually have a custom made spring washer that I'm shipping with the product. So you don't have to use Loctite anymore. I had a number of people had their fan come off because the nut came loose. And, of course it comes off, it gets destroyed, right? Because it's spinning, you're driving a thing and it's spinning really fast and then all of a sudden it comes loose, right? And so I wanted to eliminate the need for Loctite. And so I've got a custom now spring washer that I'm shipping with the kits, but to keep it in place without having to use Loctite.
Nice. And then with the Evolution 2 cooling setups, how many of those have you sold?
Yeah. On the newest stuff, I think I have in the neighborhood of about 45 pre-orders. This stuff will start shipping at the end of the month.
And that's the Evolution 2. That's
the Evolution 2.
And is that sold as a complete kit? The Evolution 2.
Yeah, so you get the combination air inlet backing plate that you put onto your alternator or generator, along with the fan itself and all the mounting hardware. And so that comes as a complete kit. So you get everything you need, and you don't use the original backing plate stuff at all.
Interesting. So when I'm on your website, let's say I was looking at one of these, if I go to the Evolution fan system, let's see, Evolution fan shroud velocity ring. So that's the system and the ring. So the system's $400 for the shroud.
If you get now on the complete cooling system that comes with the fan shroud, that's we want to be really clear, right? When I said 28.9%, that was for just the fan kit that goes into a doghouse fan shroud.
Right.
The complete cooling system, there's an Evolution 1 complete cooling system and an Evolution 2 complete cooling system.
Right.
Those are 110% increase in airflow, so more than double.
Oh, really?
And 128% increase if you go with the Evolution 2 complete cooling system.
128% over the stock doghouse setup.
That's right.
That's got to make a massive difference for driving.
Yeah, it's huge. It's huge, right? So when you talk about, you want, big engine, and you want to cruise at low RPM, right? I mean, those setups are tailor-made for those kinds of, configurations where you've geared the car in such a way that you want to cruise at a very low RPM at, high speeds. Those are the ones that, would really cool those engines really, really well.
And so you're 419. So if they get that for 419, that's the Evolution fan. And that's and that's
you get the fan shroud, you get the fan itself, you get an oil cooler block off with that, because that fan shroud is not a doghouse style. It's requires an external oil cooler. So you get all the pieces you need there. I don't sell the external oil cooler and that kind of stuff, but it does require external oil cooler. And so there's two versions of that: an Evolution 1 version, an Evolution 2 version, and then also it has an optional velocity ring that you can add on top of it. So for an Evolution 1, let me just stop and start with just the fan shroud, because the fan shroud will work with the stock fan. So if you just do the fan shroud, you get a 52% increase in airflow with the stock doghouse fan.
So if you buy just the fan or just the fan housing, just
the fan shroud,
you get a 52% increase. So you got multiple stages of airflow increase.
Right. So you get 52%. Then if you add the velocity ring, you're at 59, a little over 59%. Then if you step up to an Evolution 1 fan without the velocity ring, that's 110%. Then if you add the velocity ring, that's 117%. Then if you go Evolution 2, you're at 128%. Add the velocity ring to that, you're at 135%, right? So starting all the way down from, because I sell velocity rings also now for the doghouse fan shroud and the early fan shrouds. So you can start from velocity ring at a little over 7% increase in airflow just by adding a velocity ring, keeping everything else the same, to then the Evolution 1 fan, 11% to 18% with a velocity ring, to 28.9% with the Evolution 2 fan, then add a velocity ring to that, over 36%, then go up to fan shroud. Now you're at 52%. Then go 59% with a velocity ring. Go up to Evolution 1 and my fan shroud. You're up to 110%, then 117% with a velocity ring, and then 128 and 135 at the very top end, right? So I've got now from a small under 10% to well over double the air cooling capacity, the airflow capacity.
That's wild. That's
wild. Depending what you buy. So
and I wonder. So when you do the dual intake fan, is it more drag on the motor because you're now pulling in more air and turning more air?
Yeah, it definitely increases the horsepower draw. But again, it's what's interesting about that one. As soon as you go dual inlet, the efficiency actually improves even more. So again, you're talking very small change in horsepower. So the difference between like an Evolution 1 and an Evolution 2 in terms of horsepower draws is like 0.1 horsepower. It's really small. So you get more efficiency, so you get more airflow, but you don't pay a super high price for that airflow. So that one's even more efficient.
I would love to see dyno testing, and like not only dyno testing, but like real world temperature tests with a setup, just like putting each piece on and running it through a dyno sequence. You know what I mean?
Yeah.
I think it would be interesting to have the actual data numbers just to see with respect to temperatures.
Yeah, with the same engine.
Yeah.
Yeah. Yeah, I would love to be able to do that. I don't have a dyno. So if there's somebody out there listening who wants to do this,
well, I
would partner with somebody to do that.
I have a friend that has a dyno here in town, so here in Las Vegas. So maybe we'll see if I can't, because I'm looking at one of your setups. I'm like, maybe I should buy one of these for one of my cars just to see how they work. Now, have you toyed with the idea on the Type 3 cooling systems at all?
I have, actually. I've had a number of people, both Type 3 and Type 4, ask for, hey, can you develop something for Type 3, Type 4? And I bought a bunch of used Type 3 parts, and I do have a prototype sitting on my desk here in my office of a Type 3 fan. It's more complicated, actually, which is kind of maybe seems silly since but it's because it's mounted to the crankshaft, the end of the crankshaft.
Right.
So it's a little more complicated. I've got to really design more pieces, and actually the Type 3 has two fans on it. The regular squirrel cage, centrifugal fan that everybody's familiar with, and then the pulley that actually drives your generator, or an alternator, but generator in stock form, is also an axial fan.
Right.
So those were made out of magnesium, and there's a bunch of different versions of them that have different timing marks on them, and depending what year, and it's really interesting in terms of that kind of stuff and how they fit together. So really, to do it right, I would actually need to make both the fan and that pulley that is also a fan, make both of them. But I do have a design for both. I do have a prototype fan, and I do have even a velocity ring worked out for it. So I'll probably continue working on that. I'm really interested. There's not a lot of Type 3s out there, but it seems like at least the people that have talked to me. So if you're a Type 3 person out there and you're interested in this, the real key is going to be how much are you willing to pay? Because some of the parts, to make some of the parts, is going to be a little pricey. The fan itself will have an upfront cost for a mold that will be pretty expensive, but I know what that cost is, and it's not too bad. That I think works. The pulley / axial fan that goes on the top of that, that piece, either I just don't make it at all, but if I don't make that piece, I can't optimize the fan behind it. Right. So it's somewhat of a little bit of a catch-22. Really kind of have to make both things. But I believe that, I can pretty easily make something that works much better than the stock components. But the pulley part that's also the axial fan, that's probably the kicker in terms of expense, manufacturing expense. I do have a quote for one. So kind of know, and I can drive down scaling that up depending on how much is made, but I don't know how many will sell. That's the thing. Yeah. So there's not that many Type 3s, unfortunately. I like a lot of the Type 3s, but is there going to be enough demand, to get a more reasonable cost of manufacturing for that, or are people willing to spend that? And I think somebody from, who are the big Type 3 parts guys? I'm forgetting their name. ISP West. Right. Someone from ISP West a long time ago now, kind of pinged me about something. So maybe there's, if there's enough interest from enough people, and maybe, they would, if someone like an ISP West might be able to buy enough upfront inventory kind of thing, to make it worthwhile, maybe the numbers start to work out. So, I can tell you with it, there's a guy, and I want to say his name is Kevin Nash, and he's doing a radial fan for a Corvair. And I'm aware of that one. And they're machined in billet aluminum. And the process that he's doing is he does a preemptive order, like, okay, if I get so many people together that will go in on an order, I can put the fans into production. You know what I mean? So maybe there's something like that. You just figure out the number that you get. And when you get that many people that are reserved and that commit to buy, and then you just pull the pin and once you agree to buy it, there's no going back, because you can't. Once you put the order in place, there's no turning that around. But if you figure out that number and you get to development point and all that stuff, and we want to get you back on the podcast, by all means, we'll get you back on and talk about that. Because I just definitely think it's something cool that you're doing. It's something that a lot of people take for granted in the hobby, of people that go out of their way to try to make something because they want to make the hobby a little bit better. I'm all for it, and I think it's really cool, and I definitely appreciate what you do. Now, is there anything else that we didn't touch on that you think we might need to touch on before we wrap up? No, I think that was most everything. I mean, we definitely covered almost everything I sell. That's for sure. So at least at the moment, and things I'm thinking about developing. So and I had some other things on the back burner as well in the hobby that I'd like to do at some point. I don't know if I'll be able to get to it, but we'll see what happens with this business. It's been a real roller coaster, up and down. But sometimes it's going like gangbusters, and then sometimes you're swatting flies. Yeah, and so you never know really kind of how, like you said earlier, and as we were talking, sometimes people buy stuff and then they don't install it, right? And it just sits on a shelf. I just had a customer just very recently. It's like, oh yeah, I bought 2 of your, fans, 3 years ago, and I'm just now getting around to installing them, and I'm having this trouble. They won't install. They keep rubbing here. and it, and he's sending me information and pictures and stuff, and I'm like, none of that really makes any sense. He eventually figured it out. I didn't figure it out. He figured it out. He had a problem with his backing plate, but he bought a new backing plate, and then everything just fit just perfect. So you never know. Things sit there, and so sometimes it's like no news is not good news.
Right.
Sometimes, you know what I mean?
No news is bad
that
news.
kind of stuff in this business. So sometimes no news is bad news. And so, it's been up and down, but I really feel like, business is at a point now as I start shipping Evolution 2 at the end of the month, beginning of June, and start shipping that. Because these are big investments. People don't realize what it costs many times to get these things off the ground. The business seems to be on solid footing now. So I think, if I make it through this year well, if things keep going well, the rest of the year, like it kind of has so far this year, I think I'll be at the point where, I know the business will sustain itself, right? I don't have to invest more capital into it.
Right.
And I'll be able to keep going and then develop other things that I'd like to develop it over time. So,
well, and hopefully the podcast will bring you some people because there's a lot of people listen to the podcast but they're not on the forum boards and they're not over here.
Yeah.
And there's interesting because our hobby has so many different type of people. I mean, the demographic that listens to this podcast is all over the place because there's young people that are in a podcast. Older guys don't really listen to podcasts, but some guys like my age in their 50s, I listen to podcasts all day. You know what I mean? So it's just it's an interesting spread of a demographic, and I'm curious to see how many people reach out to you after this podcast because it's definitely something interesting that it's always trying to build the better mousetrap with this antiquated technology that all of us love so much, and we try to put so much time and effort into trying to make it keep up with modern day stuff that's out on the road today. So
exactly. And I've loved these cars, since I've had them, and to me it's kind of a pleasure to be able to give a product to somebody, and then I get the customers who do give feedback, it's like, oh wow, it's so, had a guy from Australia. He's like, oh, my oil temps dropped 10 degrees. I don't have to buy an external oil cooler now. You saved me from doing that, right? And you get that kind of feedback, and that's always great. To say, hey, you're making something that people find valuable. It really works. I don't sell snake oil. There's lots of times. There's some products even still today on the market out there that some people are like, telling me they have product X, and I won't say what the product X is, right? But, because I don't like to really disparage anybody. And I'm like, I know that doesn't work, and and then kind of gently telling customers, like, sometimes like, you really should think about this, right? And here's the problem with that, what you're using, and this, might be part of the problem that you're having with, with your car, right? So, it's, and getting to a point where, sustaining a small business, right, is, that'll be a big milestone. So
that's a lot. Well, hey, maybe we'll see. I don't know. What side of Colorado are you on? How far are you from Las Vegas?
I'm in Strasburg, which is the eastern high plains of Colorado. So I'm about, let's see.
You're a ways.
I'm directly east of Denver by, how many miles is that? Probably 30 miles from Denver. I used to live and the business used to be in a couple, very close to Boulder, but we moved out into the country side. But yeah, if I'm ever going that way, one of these days I've kind of had this dream that I'd go to SEMA one day.
Yeah.
If that ever happens, maybe we can hook up together and
for sure. Well, listen, we do a big event out here, one crazy weekend every October, and it'd be something cool to come out here. There'll be a few hundred cars out here, and it's a weekend long event, and it's a pretty good time. So if you're interested in coming out and about this way, I'd give you a vendor spot out here if you wanted to come out and
Cool.
show off what you
Yeah.
did. For sure the desert rats love it.
Yeah.
And so yeah,
Yeah.
no, listen, I'm glad we're able to get you on the podcast and talk about this, because I've been looking at this for a while and wanting to just kind of get some information. So we definitely have a lot of information. And I do have to ask one question. Andrig, what kind of name is Andrig? What kind of name is that?
Well, yeah. It's actually made up.
Is it?
My grandfather on my mother's side, my mother is from Puerto Rico, and so she passed away back in 2022 along with my father.
Sorry to hear that.
That's okay. And he actually passed away when my mom was only like 9 years old. But his name was Ignacio Andres.
Oh, wow.
And then he named his son, my mother's brother, my uncle, Ignacio Andres as well. And so there's two Ignacio Andreses in the family. So let's make up a nickname, right? So they made up Andrig or Andrig as a nickname, which is the Andres is the ANDR and the IG from Ignacio, and put it together as a nickname for my uncle.
Nice.
And then I was named after my uncle, so I got it as a real name. It was his nickname growing up, and still is. And we always just called him Uncle Andy, actually. But that's how I got the name, and so it's definitely unique. And I gave it as a middle name to my son, so there's at least one other person in the world that has the name. But
That's it. Wow. That's awesome. Well, man, Andrew, I appreciate you coming on the podcast, man. I look forward to anything else you come out with development wise and all that stuff, because, I'm here to get the news out to the hobby of people that are doing stuff. And maybe we'll for sure circle back on some testing data and some things like that, just to kind of see what some real world performance stuff does in a controlled temperature environment. A controlled environment dyno room would do. So that'd be great. Interesting to check out. But
that would be awesome.
Well, man, thanks so much for getting on the podcast. If people want to reach out to you, what's your website?
It's andrigs.com is the short version. And that's a redirect so it's just ANDRIGS.com. And it redirects to andrigsaircooltechnology.com. So.
Very cool, man. Well, I appreciate the time you took with us today, man, and coming on the podcast. And I look forward to hearing more from you in the future as you go on to develop more things, man.
Great. Yeah, I appreciate it. Thanks, you, Bill.
You got it. Well, there you have it, guys. Hopefully you have all your questions answered that you had about the fan that Andrig makes and some of the other components. So I'm excited for, modern development in our air-cooled world. I love stuff that creates controversy just because there's a lot of naysayers out there. And I'd love to see the development and innovation happening. So you guys want to support the podcast, go to letstalkdubs.com, click on the merch tab and support the podcast. Also support the sponsors that support Let's Talk Dubs. And this weekend is going to be the first time I'm taking out flyers for One Crazy Weekend. We've got a lot of rooms booked already. Don't miss out, guys. 30 days before the event, the room booking is closed. So make sure. Remember, this is Vegas. This ain't podunk nowhere. Get your rooms booked today for the best time you're ever going to have in your Volkswagen for One Crazy Weekend. That's October 2nd through the 4th, taking place here in Las Vegas, Nevada. Some of the exciting stuff that I can promise you is Thursday is going to be partially a free day, and then there'll be a poker tournament in the early afternoon or late afternoon, early evening. That's brought to you by VW Trends, where you're going to sit down and play a poker tournament against other VW enthusiasts for VW prizes. It's going to be a great time. That will be taking place on Thursday. The free time events, last year, Punk Rock Museum, we had 25% off, or we had locals discount. So I'm working on that with some other local places. So as you cruise around Vegas on a Thursday where it's not crazy traffic, you get to cruise your Volkswagen around Vegas, go check out some local touristy things where you get treated like a local, you get discount, you get preferred parking if possible, and then you have the poker tournament that evening. So that's a card poker tournament, casino style, taking place inside the hotel. And Friday is going to be a bowling tournament taking place that's going to be put on by Ross Wolf. I know George T. at the Wagon, super excited because he considers himself a pretty good bowler. I'm a lucky straight shot guy, so I'm the kind of guy that could show up and just ruin his world by being zero skill and getting high score. So I'm going to do my best to do as much destruction as I can. And that bowling tournament will be taking place on Friday, and then later in that evening we have the strip cruise. That's right. Last year we had 150 cars on the strip. This year looking for even more. So that'll be taking place Friday, and then Saturday is the car show, 8 a.m. to 1 p.m. after the car. And listen, I got extra cool things planned for the top 20 medallions that go around people's neck this year. So we're going to be blinging you up this year, and that'll take place 8 to 1 on Saturday. And then everybody goes, takes a break. Some people go to the pool. Some people go back to the room to try to get caught up from their night of having a rager on Thursday and Friday. And then at 5:30 p.m., we kick off the world famous poker run, where that's right, we're going to give away over $3,500 in cash and prizes. So I'm excited for that. We love giving away cash here at One Crazy Weekend at the car show. So I'm excited for all that. It's going to be a rager of a year this year. On top of that, we're moving to the top of the parking garage, where we get a whole view of the world famous Las Vegas Strip. You cannot believe the backdrop we're going to have this year. So make for the most awesome pictures. And I'm excited for all this. I'm excited for this year coming together, guys. Wait till you see how we do it in Vegas. So if you haven't had, this is our 5-year 5-year anniversary. I'm super excited if you can't tell, and I'm looking forward to seeing all you guys out there. So anyway, guys, we got lots more coming up on the podcast. I never leave you hanging. All right, sometimes I leave you hanging, but look, you can't blame a guy. One-man show over here. So until next week, guys, later.
You probably don't know that there's a new Volkswagen out that doesn't look like a Volkswagen.